By the early 19th century, London had grown into one of the largest and busiest cities on Earth, yet it remained divided by an obstacle nobody had ever managed to conquer. The River Thames, wide, deep, and thick with the traffic of thousands of merchant ships, separated the bustling docks on either bank, forcing goods, workers, and travelers into a slow, inefficient system of ferries that could barely keep pace with the city's explosive growth. Bridges existed upstream, but the stretch of river nearest the busiest docks remained impossible to cross by any means except boat. Ships packed so densely into this section of the Thames that a bridge tall enough to allow their masts to pass beneath would have required an impossibly steep, impractical structure. Merchants lost fortunes waiting for cargo delayed by fog, tide, and the sheer congestion of small boats ferrying goods across the water. For decades, engineers had proposed digging beneath the riverbed itself, but every previous attempt had ended in catastrophic failure, the soft, unstable ground and the crushing weight of water above proving fatal to every ambitious plan. By the 1820s, most experienced engineers considered a tunnel beneath the Thames not merely difficult, but genuinely impossible. A fool's errand that had already claimed lives and fortunes without producing so much as a usable passage beneath the river's murky surface. The man who would eventually solve this seemingly impossible problem drew inspiration from an unlikely source, a small, unassuming creature that had long plagued ship hulls throughout the maritime world. This French-born engineer, already renowned for his mechanical ingenuity, had spent years studying how a tiny marine organism managed to bore through solid wooden ship timbers with remarkable precision and safety, protecting itself from collapse with a hardened shell as it tunneled forward. Observing this creature's method closely, the engineer conceived a radical idea. What if a similar principle could protect human workers as they tunneled through soft, unstable ground? Rather than digging directly into loose earth and risking immediate collapse, workers could advance behind a protective mechanical shield, excavating small, manageable sections, while the structure itself prevented the surrounding earth and water from crushing them. This wasn't merely an incremental improvement over existing tunneling methods. It represented an entirely new philosophy of underground construction. Previous engineers had approached tunneling as a battle to be won through raw excavation speed and reinforced timber bracing. This engineer proposed something fundamentally different, a moving, protective structure that would allow methodical, controlled progress through even the most treacherous and waterlogged ground conditions imaginable. Bringing this revolutionary concept to physical reality required years of careful engineering refinement. The final design consisted of a massive iron and timber framework, divided into dozens of individual compartments, each one large enough to hold a single worker who could safely excavate a small section of earth immediately in front of them, while remaining protected on all sides by the surrounding structure. As each worker cleared their designated section, the entire shield mechanism could be advanced forward using powerful screw jacks, effectively allowing the tunnel itself to be built one careful, controlled increment at a time. Behind the advancing shield, bricklayers would immediately construct permanent brick and mortar lining, sealing the newly excavated space before groundwater or unstable soil could cause any structural collapse. This invention represented genuine engineering genius, but it also demanded extraordinary financial investment and manufacturing precision unprecedented for its era. Iron founders worked for months crafting components heavy and complex enough to withstand tremendous pressure while remaining precisely calibrated enough to function as intended. When investors and fellow engineers finally saw the completed shield mechanism, many still doubted whether even this remarkable invention could truly overcome the treacherous conditions lurking beneath London's ancient, waterlogged riverbed. Once construction finally began, workers descended into a vertical shaft sunk deep into the riverbank, beginning the painstaking process of tunneling horizontally beneath the Thames itself. Conditions inside this narrow, dark passage were nothing short of miserable. Workers labored in near total darkness, illuminated only by flickering oil lamps, breathing air thick with dampness, mud, and the ever-present stench of raw sewage that regularly seeped through London's notoriously polluted river. The ground beneath the Thames proved far more treacherous than even pessimistic engineers had predicted. Rather than solid, stable clay, workers frequently encountered pockets of loose gravel, waterlogged silt, and pure liquid mud that threatened to collapse into the tunnel at any moment. Each excavated section required immediate, careful reinforcement, workers moving with agonizing slowness through ground that seemed determined to swallow their entire painstaking effort. Beyond the physical misery, workers faced genuine, constant danger. The river above pressed down with tremendous, invisible force, and everyone involved understood that a single serious breach could mean instant, catastrophic flooding with virtually no chance of escape for men working deep underground in a narrow passage with only one direction leading towards safety. Despite these dangers, desperate workers continued arriving daily, drawn by wages that, however dangerous the work, still exceeded what many could earn anywhere else in London's competitive labor market. Despite every precaution, the treacherous ground beneath the Thames eventually overwhelmed the tunnel's defenses. Without warning, a section of unstable riverbed gave way, and water began pouring into the tunnel with terrifying speed and force, transforming the narrow underground passage into a genuine death trap within moments. Workers scrambled desperately toward the exit shaft as icy river water flooded the tunnel behind them. The roar of rushing water mixing with panicked shouts as men fought their way through darkness and rising water toward the only possible escape route. Some workers were swept off their feet entirely, saved only by quick-thinking colleagues who pulled them back from the water's crushing current. Miraculously, despite the sheer terror and chaos of the flooding, most workers managed to escape with their lives, though the tunnel itself now lay completely submerged, filled entirely with the very river it had been built to pass beneath. This catastrophic setback threatened to end the entire project permanently, representing not just a devastating physical failure, but a crushing blow to public confidence in an already controversial and expensive undertaking. Yet, remarkably, rather than abandoning the project entirely, the engineering team began immediately planning how to seal the breach, pump out the flooded tunnel, and resume construction despite having just witnessed firsthand exactly how catastrophically wrong this ambitious endeavor could go. As the original engineer's health began declining under the tremendous stress of managing this increasingly dangerous project, leadership responsibilities gradually shifted toward his son, a young, ambitious engineer eager to prove himself worthy of continuing his father's audacious vision. This young man, still in his early 20s, took on responsibilities that would have challenged even the most experienced construction supervisors. Working conditions had grown no less dangerous despite lessons learned from the previous flooding disaster. The young resident engineer spent countless hours personally supervising work deep within the tunnel itself, understanding intimately every technical challenge and constant danger his workers faced daily. His hands-on leadership style, unusual for an engineer of his social class and era, earned him genuine respect among the rough working-class laborers who might otherwise have viewed him as simply another distant, privileged supervisor. This young engineer implemented additional safety measures and refined construction techniques based on hard lessons learned from the recent catastrophe, determined to prevent any similar disaster from occurring again. Yet the fundamental danger inherent in tunneling beneath a major river remained unavoidable, no matter how careful or innovative construction methods became. Everyone involved understood that continuing this project meant continuing to gamble with their lives against the crushing, patient power of the Thames flowing silently above their heads. Flooding represented only one among many dangers threatening this ambitious underground project. The polluted waters seeping through the tunnel walls carried with them dangerous concentrations of methane and other flammable gases, byproducts of decomposing sewage and organic matter that had accumulated within London's notoriously filthy river for generations. These invisible gases created constant risk of explosion or fire, a danger made even more severe by the oil lamps required to illuminate the otherwise pitch-black underground passage. Workers reported experiencing dizziness, nausea, and disorientation from prolonged exposure to foul, gas-laden air, symptoms that modern understanding would recognize as genuine poisoning from the toxic underground atmosphere they breathed for hours during each grueling shift. On several occasions, small fires actually broke out within the tunnel, forcing panicked evacuations through the same narrow, dark passages that made every emergency exponentially more dangerous than it would have been on the surface. Combined with the ever-present threat of catastrophic flooding, unstable ground, and the sheer physical exhaustion of prolonged underground labor, workers on this project faced a genuinely unprecedented combination of hazards, each one capable of ending lives within moments, all simultaneously present in the confined, suffocating darkness beneath London's ancient river. Years into this exhausting project, disaster struck a second time, even more violently than the first. Water once again breached the tunnel's defenses, flooding the passage with terrifying speed, while the young resident engineer himself remained trapped deep within the tunnel, personally overseeing dangerous repair work when the catastrophic breach occurred. As water surged through the passage with overwhelming force, the young engineer found himself fighting for his very life, swept along by the crushing current while attempting to guide panicked workers toward the distant safety of the exit shaft. He suffered severe injuries during this desperate escape, nearly drowning in the chaos before finally being pulled to safety by workers who had themselves narrowly escaped the flood's devastating force. This near-fatal experience left the young engineer with injuries requiring months of painful recovery, during which he could do nothing but watch from a distance as the flooded tunnel sat abandoned, its future entirely uncertain. Several workers were not as fortunate as their young supervisor, losing their lives in this second catastrophic flood. A tragic reminder that no amount of engineering innovation could ever completely eliminate the genuine mortal danger inherent in this extraordinary, unprecedented undertaking beneath one of the world's busiest rivers. Following this second devastating flood, the project's financial backers lost virtually all confidence in the endeavor's viability. Construction funds, already strained by years of unexpected setbacks and repeated catastrophic flooding, dried up entirely, leaving the partially completed tunnel sealed, abandoned, and slowly deteriorating beneath the murky waters of the Thames. For nearly 7 years, this ambitious engineering project sat completely dormant, its unfinished passage flooded and forgotten by all but the most stubborn believers in its eventual completion. Public opinion largely turned against the entire undertaking, many considering it a costly, dangerous folly that had already claimed lives without producing any practical benefit whatsoever for the city it had originally promised to serve. During these silent years, the young engineer who had nearly died completing his father's vision found himself unable to work on the project at all, forced instead to pursue other engineering opportunities, while the tunnel he had risked everything for remained submerged and seemingly forgotten. Yet throughout this prolonged period of apparent failure, both father and son continued quietly working to secure renewed financial backing, refusing to fully abandon a project that had already cost so much in both money and human suffering. holding on to stubborn hope that this seemingly impossible endeavor might yet be brought to successful completion. After years of persistent effort, renewed financial backing was finally secured, allowing construction to resume on the long-abandoned tunnel. This second attempt benefited enormously from hard-won lessons of the previous flooding disasters, incorporating improved reinforcement techniques and more cautious excavation methods designed specifically to prevent any repeat of the catastrophic breaches that had nearly ended the project entirely. Workers returning to this notorious construction site understood precisely what dangers awaited them, yet they came anyway, drawn by wages and perhaps by something more difficult to quantify. A genuine desire to be part of completing something that had already become legendary throughout London for its audacious ambition and repeated near-catastrophic failures. Progress during this renewed construction phase moved with painstaking caution, engineers unwilling to repeat the aggressive pace that had contributed to previous disasters. Every foot of tunnel advanced represented a small, hard-won victory against a river that had already demonstrated its capacity for sudden, devastating violence. Slowly, methodically, the shield mechanism continued its patient advance through London's treacherous underground clay, workers and engineers alike, understanding that success now depended entirely on discipline, patience, and an almost reverent respect for the genuine danger lurking in every foot of ground yet to be excavated. As construction crews finally approached the opposite riverbank, anticipation grew throughout London that this legendary, seemingly cursed project might actually reach successful completion. Every remaining foot of tunnel represented both genuine progress and continued danger, workers pushing forward through ground that remained just as treacherous as it had been at the project's earliest, most catastrophic stages. The final months of excavation required extraordinary patience and precision as workers navigated increasingly unpredictable soil conditions while maintaining the methodical, careful pace that had finally allowed steady progress after years of devastating setbacks. Engineers monitored every measurement obsessively, aware that success after so many years of struggle could still be undone by a single moment of carelessness or misfortune. Word spread throughout London that the tunnel beneath the Thames, long considered an expensive folly and engineering impossibility, might genuinely be nearing completion. Curious spectators began gathering near both entrance shafts, eager for any glimpse of progress on a project that had captured public fascination for nearly 2 decades, its dramatic history of flooding, fire, and near-fatal accidents having transformed simple infrastructure construction into something resembling genuine public drama, watched with anticipation by an entire city that had followed every triumph and catastrophe throughout this extraordinarily long and difficult undertaking. When the final section of earth finally gave way, connecting the tunnel completely from one riverbank to the other, nearly 2 decades of struggle, catastrophe, and stubborn perseverance had finally produced something no one had ever successfully achieved. A complete, navigable passage running directly beneath a major tidal river, built entirely through soft, unstable, waterlogged ground that generations of engineers had once declared genuinely impossible to penetrate. The workers who accomplished this extraordinary feat had endured flooding, fire, toxic gas, and the constant, genuine threat of sudden death throughout years of grueling underground labor. Many had begun this project as young men and finished as fathers themselves, having spent significant portions of their working lives contributing to something that transcended ordinary infrastructure construction, becoming instead a genuine testament to human persistence against seemingly insurmountable natural obstacles. When the tunnel finally opened to the public, thousands of curious Londoners descended into the passage on its very first day, walking beneath the same river that had once threatened to drown the very workers who built their path forward. They walked past brick archways illuminated by gaslight, marveling at an achievement that decades earlier had been dismissed as impossible fantasy by nearly every experienced engineer who had examined the treacherous ground beneath London's ancient, unforgiving river. What had begun as one inventor's strange inspiration drawn from a humble shipworm had become, after nearly 20 years of sacrifice, the world's first tunnel ever successfully completed beneath a navigable waterway. If this story of flooding, fire, and stubborn human determination moved you, that's exactly the kind of history we love telling here. If you enjoyed discovering what ordinary workers risked and sacrificed to achieve something engineers once called truly impossible, hit subscribe and stay with us, because there are many more incredible stories like this one still waiting to be told. See you in the next video.